For tonight's video, I'm going to go through some review problems. So you want to just have a sheet of lined paper and your calculator by your side if you have it. And you're going to copy down some problems and work them through with me. So first we're going to start off by simplifying some problems. So we're going to simplify. And let's start off with number 1. Let's say we have the square root of 2 divided by the square root of 3 minus 5. So in other words, we need to rationalize this denominator. The numerator, square root of 2, is fine. It's the denominator we cannot keep a radical in. So we multiply by 1 in the form of the conjugate of the denominator over the conjugate of denominator. What is the conjugate of square root of 3 subtract 5? It's the square root of 3 plus 5. Now, multiplying here, square root of 2 times the square root of 3 is the square root of 6. Square root of 2 times positive 5 is 5 square root of 2. Our denominator, since these are conjugates, we would FOIL, but the end result is simply going to be the product of the first term, square root of 3 times square root of 3, which is 3, and the product of the last terms. Negative 5 times positive 5 is negative 25. And 3 subtract 25 is negative 22. So we have the square root of 6 plus 5 square root of 2 all over negative 22. Our denominator is rationalized. The fraction itself cannot be simplified any further. So this is our answer. Next, let's simplify 5 minus 2i squared. No, don't distribute. Rather, this is the binomial 5 minus 2i times 5 minus 2i. And now FOIL. Product of the first terms, 5 times 5 is 25. Outside, 5 times negative 2i is negative 10i. Inside, negative 2i times 5 is negative 10i. And the last, negative 2i times negative 2i is positive 4i squared. But remember, I squared is equivalent to negative 1. So we have 25. These combine, negative 10i and negative 10i is negative 20i. And positive 4 times the negative 1 is minus 4. And 25 minus 4 is 21. So we have 21 minus 20i. Next, let's look at a radical. Next one we'll simplify is the square root of 18 a to the 9th b to the 8th. Okay, square root. So we're thinking 18. What's a perfect square that goes into 18? 18 is divisible by 9. So we'll write this as the square root of 18. We'll write as the two factors, 9 times 2. Now a to the 9th, right? We need a to an even power. We would break 9 down into 8 and 1. So this would be a to the 8th times a to the 1st. And b to the 8th, the exponent 8 is even. So that is already a perfect square. Circle our square roots. Circle our perfect squares. And now take their square roots. Out comes the square root of 9, which is 3. The square root of a to the 8th, you take the 8, divide it by 2, that's a to the 4th. b to the 4th, the square root of 2a remains. Next, let's simplify a complex fraction. let's take x over 2 minus 2 over x all over 1 plus x over 2. Okay, so we have fractions within fractions. This is a complex fraction. And what we do to simplify it is we look at all the denominators, the 2, the x. Let's write 1 as a fraction, 1 over 1, and 1 and 2. The least common denominator of 2x, 1 and 2 is 2x. So we multiply every single term here by 2x. All right, when I go to multiply here, the 2's divide out, and we're left with simply x times x is x squared. Here the x's divide out, 2 times 2 is 4, so that's x squared minus 4. Multiplying 2x times 1 over 1, nothing divides out, that's 2x. And multiplying x over 2 times 2x, the 2's divide out, that's x squared. So now we have a simple fraction. Now continue to simplify. Factor. Factor your numerator and denominator, right? The numerator is the difference of two perfect squares. X plus 2 times x minus 2. And the denominator has a GCF. The GCF here is x. Factor out x, and we have 2 plus x. Now, x plus 2 and 2 plus x are the same. They're just a different order. I can read this as x plus 2. They divide out. So our answer is x minus 2 over x. Next, let's look at simplifying (7) square root of negative 36 minus 4 square root of negative 25. The square root of negative 36. Now remember, the negative underneath the square root, that comes out as I. And 36 is a perfect square, so this is going to be 6i. So we have 7 times 6i minus 4 times 5i. 42i, subtract 20i. These are like terms. 42i subtract 20i is 22i. Next, let's take 3x minus 9 over 9 minus x squared and divide it by 3x plus 12 over x squared plus 7x plus 12. So we have the division of these two rational expressions. Two things here. First, we're going to change division to multiplication, and we're going to write the reciprocal of the fraction that follows. So the division changes to multiplication, and I'm going to multiply by the reciprocal. And in the same step here, we also want to factor. Okay, so for my first fraction here, I'm going to factor the numerator, GCF 3 times x minus 3. The denominator is the difference of two perfect squares, 3 plus x, 3 minus x. Now, my numerator now is going to be the factors of the trinomial here. The factors of 12 that added to 7 are 3 and 4. So x plus 3 times x plus 4. And now the factors of the numerator. now become our denominator. 3 times x plus 4. Now we can divide out common factors, common to any numerator and denominator. So the x plus 4's divide out. X plus 3 and 3 plus x are the same, but the x minus 3 and the 3 minus x, they are what? Opposites. So we'll divide them out and replace either in the numerator or the denominator. We replace a -1. Not done quite yet. The 3's also divide out. So all our factors divide out, and we are left with -1 over 1, which is -1. Okay, so that's enough for simplifying. Let's factor. All right. Let's do one factorization. Let's factor 6x to the third plus 21x squared minus 6x minus 21. First, GCF, is there one? Yes, 3. Factor out 3, and we have 2x to the third plus 7x squared minus 2x minus 7. Now, the polynomial inside parentheses contains 4 terms. So now, 4 terms, think grouping. Draw a line after the second term. Copy down the sign that follows it. Now, to the first 2 terms here, what's common to 2x to the third and 7x squared? It's x squared. Factor out x squared, and we have 2x plus 7 in parentheses. And to the next 2, 2x and 7, the only thing common is 1. We're actually factoring out a -1, so that when we do that, we end up with 2x plus 7 in our parentheses. And what's in parentheses should match, and it does. So 2x plus 7 is one factor, and then what's left outside, the x squared minus 1, is the other factor. And let's not forget to bring down our greatest common factor of 3. But we're not done quite yet. One more factorization. This is dots, the difference of 2 perfect squares. This factors into x plus 1 times x minus 1, bringing down the 2x plus 7 and the 3. So here is our complete factorization. And this will conclude tonight's video. Thank you.